Good afternoon, everybody. Thank you for joining this Safer Sim webinar. We are getting back into the swing of things after the holidays and the new year. We just came back from our Safer Symposium at University of Central Florida earlier this month, but we do have a full lineup of webinars planned for this semester. Starting off today, we have Dr. Kelvin Santiago from the University of Wisconsin-Madison, and he is going to be talking about some interesting work they are doing there using driving simulators for virtual road safety audits. And I will let you take it over from there, Kelvin.
Okay, thank you, Jacob. Well, thanks everyone for attending and taking the time to listen to this webinar and kind of see what some of the things that we have been doing here at the University of Wisconsin-Madison. Like Jacob said, I'm going to be talking about how to use driving simulators for virtual road safety audits, and what I'm going to be focusing about is what have we learned as we've gone through this process. So we've done full-scale driving simulator, we've done lower-scale simulation. So I want to talk about those two experiences, as well as other things that we learned that are not related to the simulation component, but about the benefits that using simulation introduces into the process. Okay. The outline for the presentation, I'm basically going to talk about what are the goals for the project. Why do we decided to go with a virtual road safety audit? What is it? What is that background and motivation? What everyone thinks it is and what it ends up being? What are the scenario creation alternatives? We're going to have to create a scenario. What are those challenges associated with it? How does that impact your deliverable? What are the experimental alternatives? We have different ways, and as you can imagine, things are going to cost more money if they are higher end than lower end. I'm also going to be talking about how can we move forward? How can we make this process a little bit more objective in terms of the evaluation? Some technologies that we have developed that can be used to identify candidate size for road safety audits or virtual road safety audits. And then we're going to talk about some of the conclusions. Okay, so in terms of the goal, if we start thinking about a virtual road safety audit, what is it and what are the challenges that took us to this point? When you do a road safety audit, if you're familiar with the process, it basically involves people going out on the field. You have a team that goes out to the field and evaluates a site. Now, that site is evaluated because you have the perception that there might be a safety problem, or you know there's a safety problem because crash data tells you, or you're being very proactive and you have a new design and you want to see, could I actually have a safety problem in here? So road safety audits in the traditional sense don't necessarily need to be conducted on a site that is already built. They can actually be conducted on a site that hasn't been built already, and that's a very proactive approach. So I mentioned the team. That means that you have typically engineers, law enforcement, first responders, that kind of insight into the safety audit, because you want a more bird's eye view of safety. You don't want just to focus on technical aspects of the component. So you want to bring a diverse team that tells you, okay, there could be problems in here. Now, a virtual road safety audit, it takes a road safety audit to a step further. One of the limitations of the road safety audit is that you are actually just analyzing or looking at a site from an expert perspective. Now, the team might be diverse, but you should try to go for experts anyway. So you have law enforcement personnel providing a law enforcement perspective. So those are experts. Even more, one of the challenges with road safety audits is that you don't have an insight into what the humans are doing. You might see a behavior. You might see that this person took a little bit longer to cross the road. You might think that it's because of an obstruction in the line of sight. You might think that it's because of distraction. You might think because of traffic. You might think that it's because of age. You actually have no way of quantifying the reason as to why that happens. So that's the challenge with the road safety audits. Okay. Now, a virtual road safety audit basically lets you take the human, putting in a scenario in which it will replicate the conditions of a particular site, a site that has already been built or a site that has not been built. So we use driving simulation or some sort of simulation to actually study how the driver reacts to certain conditions. That means that we can say, okay, this driver, we see that it's taking longer to cross. It's because of a confusing sign or because of a confusing indication. We can actually answer why what we observe on the field is happening. So that's how we introduce a human component into the road safety audit process through the use of a virtual road safety audit. Okay. Now, one of the main challenges. Okay.
Should be getting back to normal there. Yep.
Okay. Okay, I got scared for a second. Okay, so one of the main challenges with the virtual road safety audit is the creation of a scenario. And for those of you who don't drive in simulation, you probably have seen the response of people. It's like when they go to a driving simulator, this is what everyone thinks. And I like this picture because it's very realistic. It's like, wow, this is a very nice, nicely created scenario. And this is what everyone thinks when you start seeing when you talk to them. It's like, oh, I'm doing driving simulation. Let me show you the simulator. Everyone says like, oh, it's gonna be like that. It's gonna be very realistic. Then this is what happens. You realize that they go in there and they realize like, oh, these are the tools that I have to create a driving simulation. You're faced with low quality textures. Now you have some high quality textures, but still you're so constrained. You're so far away in terms of the scenario of how the real world looks and how your driving simulation scenario creation tools look, because scenarios are trying to be generic, so there are no tools to actually recreate an existing site without having to use more advanced tools. So when you have students or engineers creating scenarios, you cannot use the tools that they're used to for generating nicely looking scenarios. So you're stuck with things like this. So we have to find something in between. And one of the reasons that we need to find something in between is because what you see on the screen right here on the left side is this is what you get from a driving simulator environment. This is what people want. Okay. You can imagine that creating that type of scenario takes a lot of money. If you've heard numbers from the game industry, you're talking about the creation of a game is on the hundreds of millions of dollars. I have never seen a driving simulator project with hundreds of millions of dollars budget. So you have to set your expectations right, and it's like, what are your needs? How do you balance those two things? Okay, so you have to be careful with those things. Now, there are different ways that we can create driving simulator scenarios. One of them, I call it an extrusion-based procedure. That means that you have the alignment of the road, and this data that you can typically get from the design of a site. You can go drive a vehicle with GPS. There are multiple ways like you can extract the alignment of the site, and then you extrude a typical cross section. And I'm going to talk about what I mean by extrusion, so don't worry about that. But what you see on this picture in here is actually something in the scenario. You see that it's extruded, and what I mean by that is kind of continuous. You see that there are no changes in the cross section in the foreseeable distance. And when you start thinking about it as well, that's not how reality works. It's like actually most of the time that's how roads work. You have a cross section that you repeat for a long distance. Granted, in urban environments, it's not necessarily that way because of the roadside, but your road still looks the same most of the time until there's a change, and then that change continues, and then there's another change, things like that. So an extrusion process, the way we can create those, basically we go out to the field, we do the measurements, so we take those from the design drawings, things like that. So we basically extract those, define your cross section for the typical site that you're trying to study, identify how many of those cross sections do you need, and then you can actually go ahead, input that cross section information into your 3D modeling software or your scenario creation tool, and you reach to something like this in here. Now, this what I'm showing on the screen, this table in here, that's actually related to another project that we had under Safer Sim, which allows us to specify the cross-section information and then generate a 3D model. The reason this is beneficial for a road safety audit is because one of the challenges with creating, with doing driving simulator experiments, is that, at least from the civil engineering perspective, you often want to study something that is not a standard tile. So you need to create those, and that takes a lot of time. So we already have tools that let you streamline this process, at least the model from the modeling perspective, so you don't have to have someone constantly doing 3D modeling, which takes a lot of time. So we've automated some of that tasks that are beneficial for the virtual road safety audit process. Now, as you can see, once we put it through that kind of software, we can generate a 3D model that looks more realistic. Now, when you start looking at the textures in here, what I'd like to point out is that just the pavement textures alone, the kind of stuff that we can achieve with automated tools that have been created for this process, it's so much better than what you typically get from a driving simulator manufacturer. So the texture quality, you can actually go to the site. These are textures that were taken by going to a site, taking pictures of the road, and using those pictures to actually build the textures. At the end, you have to balance things. So once you have a 3D model that you have extruded, you need to add some roadside information. And this is where you have to make some sacrifices. If you're trying to recreate the entire roadside that you see, that's going to take a lot of time. That's going to take a lot of resources. So it's not really a feasible option in most situations. So you have to, decide what you really want in the simulation. In this case, under this scenario, we put out a cross-section and then kind of populated the roadside with random terrain. That's kind of an alternative when you're doing this kind of experiment. So that's what cross-section extrusion means. You take some specific geometry, you extrude it, you put it through a modeling software, automatically texture it, and you have a pretty useful driving simulator scenario. Now, another procedure, which is what most people will probably go for, and it's very useful if you have the CAD drawings, is actually taking the CAD drawings and going from the CAD drawing to the driving simulation environment. And one of the challenges that you'll have with this procedure is that I can mostly guarantee you that there's no tool out there that lets you go from what an engineer uses to create a design to what the driving simulator uses to create a design. So from this perspective, you're going to have to, number one, get the design drawings from the engineering team. Number two, clean up those drawings. There is a big difference between how design happens for creating construction drawings to how design needs to happen for creating a driving simulator environment. So let's assume that you get the design drawings from the team and you want to use those in your driving simulator experiment. You're going to use the software that you want. You need to have a conversation with your design team and ask them, what was the resolution at which you were designing? For example, we did a project in which we got the design drawings from the engineers, and they say, oh, we don't really care if the surfaces are off, if the triangles that define the surfaces are overlapping by 5 feet. It doesn't really affect our design, because at the end what we need is extract cross-section information, and we do this for planning. Now, that's great for the end, but when you bring that drawing into a 3D modeling process, what you're going to get is a very bumpy ride in the driving simulator. So that is a big challenge that we learned the hard way. We kept trying to clean things, and at the end we realized this is not a feasible solution unless we work with the design team and communicate ahead of time, knowing what we get. Because at first we thought that we're just failing on our end, something we're doing wrong, we're not importing things properly, and that was a big lesson learned with this particular approach. Now, how to go from CAD into your simulation platform, that is going to be something that's going to vary. From our end, I'll tell you what we do. Our simulator is a RTI simulator. What we do on our end is we take the design drawings from the engineer. We convert those design drawings into a DXF format. From the DXF format, we actually put it through Blender, which is open source software. In Blender, we apply the textures. We finish the model. We convert it into an OBJ format. From the OBJ format, we use MeshLab, which is another piece of software, to convert it into Vermal format. And then from Vermal format, we actually take it to our simulation authoring tool, which is Internet Scene Assembler. So again, we have CAD, which converts to DXF, DXF to Blender, Blender to OBJ format. MeshLab converts the OBJ format into Vermal, and then we import the Vermal file into the simulation authoring tool, which is ISA. Okay, so it's a little workflow, and it changes. It has changed over time, and it will continue to change as things get upgraded and things like that. But at the end, it comes down to things like this. This is a type of tool that we can create if we have the CAD drawings. There's a roundabout for which we had the design drawings. So now we can actually put things like this on the simulator. You'll see that the pavement markings or the geometry resemble things. Now these are screenshots, so they don't look exactly how they look in the simulator, but it looks even better on the simulator, because right now you're just using solid color textures in that case. But that's the kind of stuff that we can bring into the driving simulator environment. Here's another example of a CAD-based procedure. We actually did an experiment, a virtual road safety audit on this particular site. And as you can see at the bottom of the screen, basically this is a corridor that was going to be upgraded. And Wisconsin DOT wanted to know, what can we do in here for a virtual road safety audit? What can we find? It was a fairly complex design, very constrained in terms of space. So they had to make some tough choices and perhaps not common geometries or tight geometries. So we were able to put that on the driving simulator and actually study how drivers navigate to that particular design. But as you can see here, and again, these are screenshots, they look better on the driving simulator. There are flyover ramps, there are exit ramps, other exit ramps, multiple lanes, constant. The separation between medians varies depending on the position. Custom signs, again, roads, crash attenuators. A very complex design that we don't really see out there on the standard tools that come with a driving simulator. So using those CAD-based procedures that I discussed, we were able to put this design in the driving simulation. Now, something else that we try, and this was a proof of concept, is that we've actually taken LiDAR scans and be able to put that into the driving simulator. Now, on the left side of the screen, you can imagine, if you're looking at the screen, this is the driving simulation, the screenshot from the driving simulator tool, and this is a photo of the real area. Now, if you've seen driving simulator environments, you say, oh, this looks pretty good. And in fact, it does look pretty good. But I'm going to tell you that it is a challenge to do this. It is not an easy task. In fact, the picture that I'm showing you here, it's just generating a single block of the road for this type of design to bring this into the driving simulator. It actually took people who just are full-time 3D modelers, these are experienced 3D modelers, about 100 hours. So it's not something that gets done easily. It's not something that you can do for any project that you like. If you're going to go this route with creating the scenario for a virtual road safety audit, you better be aware of the limitations and the funding requirements for something like this. Okay. Now, let's talk about the experimental alternatives. What type of experiments can we conduct? And I'll give you an example of two experiments that we've conducted in the kind of related to a virtual road safety audit. First one is your full-scale driving simulator. You put this out there. You put the scenario out there into the driving simulator. You run subjects through it, and you extract all those measurements that we extract from a driving simulator experiment. So nothing new in that component, but we've been able to do this. For example, that scenario that I showed you before, the scenario with the flyover ramps and all that stuff, we actually brought people into the simulator. We brought 24 people into the simulator, asked them to basically navigate through the scenario and perform certain tasks that were of interest to the DOT. Some of those tasks involve like navigating through a pedestrian ramp. Some of the other tasks involve like finding the location of a hospital. Some of those tasks involve like just exiting the freeway because it had a different type of exit. So we asked them general questions to perform general tasks. We had to create a loop around the scenario so that people can come back into the area. But we were able to have people navigate a future design, something that doesn't exist. We asked them like, well, if you were doing this, go ahead, and we set them loose on the road and say, okay, go to the hospital. We were able to do that because of following this scenario creation procedures. Experimental design characteristics, those are on the screens. Average experience, 15 years of driving experience, about evenly distributed in terms of gender, almost no crashes, and some citations in the mix. One of the things that we did in the experiment, now I'm going to focus on one of them, is the schematic of the ramp. We asked people to actually, as they were exiting on this ramp, we asked them to make an exit. We didn't tell them exactly what they were doing, but we asked them to go around and go on this road in here. The reason we asked them to do that is because this ramp that's shown here, that I'm highlighting on the screen, it's a very complex ramp in terms of pedestrian. Because when they're navigating this cloverleaf design in here, or cloverleaf-like design, at the end there is a pedestrian crossing, in addition to a bicycle lane in this area. So now you're exiting the road, you're navigating through here, and as you navigate, at the end, you're going to face the possibility of a pedestrian crossing. So we wanted to study how people see that crossing, how people react to that crossing. Do they have enough time to react to that crossing? Do they have enough warning to do so? That's the kind of stuff we studied on the simulator. Now, how do we do that? Well, we put them on the driving simulator. You can see actual screenshots from eye tracker data in here. And what we did is we just monitored their eye tracking behavior as they navigated through the ramp. That means that we sat down through footage and analyzed the data, defined zones of interest, that kind of stuff. And what we learn in here is that a lot of the driving on the ramp, people were just so focused on navigating on the ramp that by the time they were able to identify that there was a pedestrian crossing ahead, the time they had, it was close to the reaction time. It was a little bit higher, but still, it was a little bit of concern because of the way that they navigated to the ramp. Now, the reason we did that is now we want to tell the designers like, hey, we're seeing this problem in there. Now they have that information and they can install upstream warnings or reinforce the message about a pedestrian. So that information, just simple eye tracking data, gave us that insight into the behavior of drivers. So we were able to quantify that safety concern there and take action before it gets built. So designers use that information to make changes to their signing, perhaps increase the conspicuity of the signs, that sort of stuff. Okay. Now, that type of experiment, it's a little bit challenging because it takes a full-scale driving simulator. So we say, okay, what if we take our scenario creation procedures, so we know we can end up with realistic scenarios. What if we take those and we actually put them into a lower fidelity experiment, let's call it that way. It's still some sort of simulation, but it's a pre-rendered simulation. In other words, basically people are exposed to a video and they're given the illusion of driving. So we took that type of scenario. We built a different scenario for these purposes, but using the same scenario creation procedures. We took that and we asked the question, what can we do? What if we study countermeasures that are like virtual reality-like or augmented reality-like? We put people through an experiment and we asked them to like brake when there were certain events and do some other things with those tools that you see on the screen. This device is basically a brake pedal, and this device are controlled by your hand. So we put people in front of a computer and play them a render video of the driving simulation and ask them to react to certain events. Now, we have 88 people participate in the experiment, and we basically asked them again to respond to the events. And basically when they respond to the event, they have to respond basically by pushing the brake pedal. And what we decided to study in this particular case is, how do we warn drivers of something ahead? And if we warn drivers of something ahead, do we risk confusing them? Do we risk lowering their reaction time to a dangerous event because of technology? In other words, if we use augmented reality, do we actually risk a lowering reaction time based on when we deploy that? And what we found is that actually, no, we don't seem to have an issue with that. But what we were able to get from these experiments, and kind of disagrees with findings on the literature, is that when we're warning drivers about a potential issue ahead, we should do that using like a flashing rate of 3 seconds. If we're displaying a sign, a virtual sign, 3 hertz, so 3 times a second appears to be a good rate in there. Other than that, you also find in the literature that you get into the risk of seizures and things like that. But the point here is that, again, we took a scenario, we put it on a driving simulator or driving simulator-like environment, and we were able to study things without having to put it on a full-scale driving simulator. And also, we were able to study things that are not possible through the standard tools, standard scenarios that are available through simulator manufacturers. Okay. But I want to talk now about some of the challenges of site identification, because one of the things that for virtual road safety audit is that you need to identify a site. Where are you going to perform that road safety audit? Right now, you can either get feedback from people. That means that you hear that there's a problem. You can rely on crash data. You see that there's a problem. You can rely on your own experience, thinking that there could be a problem, but it's still sort of reactive in nature, in terms that you might be ignoring sites that you're not aware of. So you will not see those sites until a certain point in time. Now, we asked ourselves a while ago, what if we could actually take a more objective approach to identifying sites with potential safety issues? And what we've done here at UW-Madison is kind of put together technology that lets us monitor the trajectory of vehicles on the field. And what we do is, because we have the trajectory of vehicles, then we can compute performance measurements across different locations and use that to determine if there's an actual problem, if there's a potential problem, and that we should take a look at that site and add a human component into it before it's too late. So on the screen, what you're seeing is basically a prototype of a device that we install inside a signal cabinet. The signal cabinet is controlled by a signal controller, which has a vehicle detection system that is radar-based. So we found a way to log that trajectory data, and that's what you see at the bottom of the screen, kind of a schematic. We get the location and position of vehicles along with the speed every basically 0.5 seconds. So we know everything that's approaching the intersection, the speed at which they're approaching, and the location where they approach. And so we track vehicles throughout the intersection, multiple vehicles at a time, up to 32 at a single time per approach. So you can imagine that we have 128 vehicles that we can track on all the approaches at most at the same time and monitor the interactions of those. The reason something like that is important is because we can talk about then the proactive monitoring. We can see, okay, now I have all the trajectory data. What can I do with it? Well, again, if we want to be proactive in identifying potential issues, we can go ahead and compute things like time to collision or post-encroachment time. In the example shown here, again, you take two vehicle trajectories, and here's your fundamental space-time diagram of two vehicles. You know that there is a leading vehicle in here and a trailing vehicle. If these two vehicles have different speeds and they are in the same lane, at every single point in time, they are in a theoretical collision path. So you can compute for every single time, every 0.5 seconds, you can say, what are the chances that if these vehicles don't change the speed right now, how long will it take them to collide? How long will it take them to collide? And you keep asking that question every 0.5 seconds. And what you are able to identify is how close to a collision those vehicles come. Then you take the average collision, the average time to the lowest time to collision for each vehicle. Then you take the lowest time to collision for every single vehicle and average it, normalize it by volume, and then that lets you come up with safety rankings for a particular intersection and say, okay, I'm having potential rear end collision issues at this intersection. Let's perhaps do a road safety audit or a virtual road safety audit at this site. So that's how we can identify these sites in a more proactive way. Another example in here that we can do with this kind of technology is actually saying, okay, if I have a right turning vehicle and I have a through vehicle, how close those vehicles come to a collision point. Why is that? Because right turn on red is allowed. Sometimes some people abuse it. So perhaps if you are detecting, if you have your intersections instrumented with radar and you're constantly collecting that type of information, you can then quantify which intersections have behavior of the right turning drivers or the through drivers that are resulting in near misses. In this case, those near misses, those almost collisions, we can compute them with what is called the post-encroachment time. And it's basically computed as, okay, the vehicle crossed at this time point in here. When does this vehicle cross this point? Difference between the times gives you the post-encroachment time. In other words, when you make a crossing, it's like, you breathe, I made it. How close were you to a collision? That's what post-encroachment time really means. So if we compute this information across different locations, we can come up with metrics that allows us to identify sites that we need to target before we actually see crash history manifest itself. Okay. Again, this is an example of stuff that this is actual post-encroachment time values across a location. So as you can see in here, there's a distribution of values that you say, okay, maybe an intersection has 4 of this per hour, 4 low values per hour, 4 near misses per hour. If another location has 10 near misses per hour, you might want to do a road safety audit on that location. Even there might be no crashes, there's something telling you, there's signals that are telling you that there could be a problem that you need to go ahead, do a road safety audit. If you think that the road safety audit is not going to be enough, go do a virtual road safety audit and try to get into the mind of the vehicles, of the drivers, by basically having them drive a virtual vehicle. So that's how we link these two things together. It's like we need to understand which sites we need to deploy our resources on. Okay. Now, for conclusions, the one thing that's clear is that the virtual road safety audit gives you a greater insight into the view, into the mind of the driver. So we're able to understand what they're thinking of, what are they trying to do, why are they doing it. However, we need to understand that there are limitations. It is a process that takes time, so you need to balance your needs with what's achievable. How much time do you want to spend in creating scenarios? What's the perceived benefit of it? Also, you need to be proactive in identifying those sites. If you're waiting for a crash to happen, then it's too late. So if you're going to have a system in which you proactively conduct road safety audits or virtual road safety audits, you need to be proactive about it. And that's why we introduced that idea of monitoring actual vehicle behavior, understanding where there might be a signal for a potential problem in the future, and then using that. The one thing that I'd like to mention, I left this for the end, is that there are unexpected benefits that you might not have thought of at the beginning of the project. Okay? And I want you to think of not ignore those benefits. Some of those unexpected benefits, I actually took a picture of the screen on it, and I'll explain what it means. One of the most beneficial aspects that we learn with our virtual road safety audit experiences is that road designers, they have at their disposal a wide array of tools. They have 3D modeling, they have visualization tools available, again, at their fingertips. So they've sat down through the designs, they understand what's going on, they know that it meets the standards, all that stuff. But nothing replaces actually bringing the designers and showing them their project in a full-scale driving simulator and having them drive through the design. Because one of the things that happened, the moment we did this, within a few minutes of them looking at the design, we brought them into the simulator, we showed them the design, they were able to drive through it. This was not a formal experiment, it's just a visualization tool. The moment they sat down in the vehicle, they realized that a sign placement, which was properly placed according to standards, was not very visible. And the reason it was not very visible is because the way that the geometry of the road was set up and the way that the geometry of the road interacted with the 8 pillars of the vehicle, you had limited view of the sign. So it was kind of really impressive seeing the designers there immediately, like realizing, like, oh, okay, let's put all their construction drawings, let's make a change in here. What if we move the sign a little bit further down, angle it a specific 15 degrees? So they were able to do that on the field. So they sat through this design for a while, and now they actually just found a way to visualize it and make changes to it. So don't ignore those benefits or unexpected benefits of the design. Now, that's it for my presentation. I'll take any questions now.
Thank you, Kelvin. So if we have any questions, I see a couple people typing away. Feel free to use that chat box for any sort of questions or comments you may have.
I see 2 people typing. Let's see what happens.
So Kelvin, here's the question from Dawn Marshall. Thank you for the presentation. The sign placement is a nice example. Are there other additional ways a virtual audit might augment real-world work?
Let's see. Don, I think I'm a little bit confused on the question. Are there additional ways a virtual audit might augment real-world work? I think it basically, if we ignore the human component in the process, the visualization component cannot be more clear in terms of power. So visualization is a key component there. For design, being able to place signs there and be able to make quick changes and test them, that's a visualization. So I think that will be the way in which we augment it. Let's see. A virtual audit narrow down the options with less expense and in less time than implementing in the real world. If yes, but it's a hard thing to quantify. Then we get into benefit cost versus cost avoidance. Removing that sign that I show you and that I mentioned, that would have been a task that will require like perhaps $200,000. That was less than the budget of the project. So yeah, it quantifies. It has ways of making things easier and cheaper with a simulator. Now let's see. You did not define any difference in the road safety audit and virtual road safety audits. The main difference in the virtual road safety audit and the road safety audit is bringing in the simulator component and being able to get an insight into the mind of the driver. If you're doing a road safety audit in your typical environment, you're only having a hypothesis about the behavior of drivers. You're not able to get and drive with every single person on the road and measure their performance. So that is a big difference in there. So the big variables that is introduced with the virtual road safety audit, it's human performance. That is the big challenge and the big difference there. And yes, this presentation will be made available. I understand that we post them on YouTube, right?
Yep, SaferSim does have a YouTube channel, and they're also cross-posted on our SaferSim website. So it will take a little bit to actually get that online, but it should be up by the end of the week, at least.
Perfect. Any other questions? I see someone typing.
Okay, I should say if there are any other questions or you would like to get in contact with Kelvin, you can send me an email, or I can send it that way. Or I'm sure you can look him up on the UW website and find his information. I think that's it for questions and discussion. I don't see anyone else typing. So we can go ahead and wrap this up. Like I said, we'll get this up online later this week, and then keep an eye out for our next webinar coming. It'll be on March 13th, and that is from researchers at University of Massachusetts Amherst. So we'll be sending information out about that next week. Thank you everyone for coming, and enjoy the rest of your day. Thank you, Kelvin.
Thank you.